This problem is called sort list. Difficulty medium, has a pretty good success rate. People love this problem. It's 279 likes to only 8 dislikes. This is asked at Google and Zenefits, among other places. The problem is to sort a linked list in n log n time using constant space complexity. Okay, so that's really the challenge there, constant space complexity. There is a in Java there's a method that you can use to sort lists. You know, you could just pass the list in there and call it the method, but I don't think that's what they have in mind here. The constant space complexity. So everything that we have here really points to doing a merge sort. A merge sort is n log n, and it doesn't require any extra space other than a few pointers, but that's not dependent on the size of the list. So it is constant space. And let's take a look at this. Here's what a list node looks like. It looks like every other list node. You have a value, you have a pointer to the next node. The final node in the list, the next pointer, is going to point to null. All right, let's see. So probably the best way to do this is to just write the main routine. There's a couple of helper routines that we need, but we can write those. Later. So merge sort, it's recursive. So if it's recursive, we need a base case. And here's the base case right here, which is that if the list is null, or if it's just a one element list, then we return the list. We return the list. If that's not the case, we're going to split the list in half. So we get a pointer to the mid node, the middle of the list, middle node in the list. And we have a function to do that, get mid, which we'll look at. We have now when we find the middle node, we're going to split the list in half there, with the middle node being the last node in the left half. So right head will point to mid dot next. And then we'll point mid dot next to null, which essentially breaks the list into two halves. We have the left half and the right half. So it disconnects the left half from the rest of the list. Recursively sort the two halves. So this is just recursive calls to this method, sort list. We sort the left half, which is pointed to by A, and we sort the right half, which is pointed to by right head. And then having done that, we have a merge routine that will merge the left list and the right list. What I want to say about this before we move on. The reason this works with the recursive calls is that we have a list and we split it in half, and then we split the halves in half, and then we split the more halves in half if we need to. Eventually we get down to where we just have one element lists, which are trivially sorted, okay, and then we can go through the process of merging them into the final list. All right. So let's look at get mid. Get mid uses a pattern called fast and slow pointers. By the way, if you're preparing for interviews, I've got a free PDF on the patterns that interviewers actually use. The link to that is in the video description below. And one of those is fast and slow pointers. So you want to find the middle node of a linked list. You can start a slow pointer and a fast pointer at the head of the list. Each iteration, the fast pointer moves 2 nodes. The slow pointer moves 1 node, so by the time the fast pointer gets to the end of the list, the slow pointer is at the middle of the list. And so that's how we can get the slow pointer. I'm sorry, the middle pointer. There are actually a couple of patterns in that PDF that we use here. One is the fast slow pointer. One is recursion, which is the heart of the merge sort algorithm. We don't actually, merge sort itself is actually not it's not one of those patterns, although in the full course we do talk about sorting. So let's see, merge. All right, how do we merge two lists? So we've got two lists as input. Now, to make this easier to merge the list, we're going to create a dummy node, a head node, and just start attaching nodes to that list. Now the while loop for the merge, while list 1 is not equal to null and list 2 is not equal to null. So that means that there are elements left in both lists. So we'll do a comparison, and whichever one is less, then we will add it to the current, we'll add it to the list. We'll add it to the merged list. If list 1 is less, then we'll add the list 1 node. And if list 2 is less, then we'll add list 2 to the merged list. And that continues until at least one of the lists runs out of elements. Now, if one runs out of elements and there are still elements in the other one, we just take all the elements of the non-empty list and attach it to the merged list. And then we return dummyhead.next, remembering that we just created this dummy node so we could attach other nodes to it. So we return dummyhead.next, and that is the merge. So that's it. Let's just review one more time here. Sort a list, sort a linked list. All right. Well, I mean, you should probably know whether or not your language of choice allows you to do that with a built-in method. Java does, but that's not what they want. They want an n log n sort, okay, and constant space complexity. That all points to a merge sort. So merge sort is recursive. Split the list in half. Sort each half. Now we recursively sort each half, meaning we take each half and split them in half and sort the halves. Eventually we split that down to single nodes which can be considered, sorted, and then we merge the lists back together into a sorted list. All right, looking at our helper methods, we're using fast and slow pointers to find the midpoint of a list. We're using recursion for the merge sort, and then the merge, you've seen this before, merging lists or merging arrays is you just put a pointer at the beginning of each list or array, and whichever one is less, then you add that to the merged result until you get all the elements. All right, now let's try it. If you found this helpful, hit like, subscribe, check out the playlist on the screen to keep improving. Most people fail interviews because they don't recognize patterns fast enough. I mapped the 12 that show up over and over. Free PDF, link is below in the the video description.